Hey, lucky day. We get to do some trig identities. I know we've been yearning for some trig identities since the beginning of the class. So the goal here is to show that the derivative of sine is equal to cosine using the definition of the derivative. So definition of the derivative means that I'll take the limit as h approaches 0 of f of x plus h, which is sine of x plus h, minus sine of x, all over h. All right, so now nothing here really cancels like it does with polynomials because I can't expand out this sine of x plus h nicely. Like I can't distribute the sign or anything. So what we have to do is we have to break out this summation formula, the sine of a plus b, which some of you may have done, some of you may have never even seen it before. If you've never seen it before, this is going to be a phenomenal day for you because you get to learn something. So the sine of a plus b has this relationship here. If you're bored, ask me to prove it. I'll prove that thing. So notice that this first term is the sine of a, cosine of b, right? So they kind of swap. And the second term just flips it, cosine of a plus b, right? So for example, if we had like the sine of, I don't know, 30 plus 45, right? If we were trying to figure out what the sine of like 75 degrees was, it would be the sine of 30 cosine 45 plus the cosine of 30 sine of 45. And then because I know you're all like trig rock stars, you know this is a half, you know this is radical 2 over 2, we know this is radical 3 over 2, we know this is radical 2 over 2. So we could simplify this to radical 2 over 4 plus radical 6 over 4. So we would know that the sine of 75 degrees is rad 2 plus rad 6 over 4, right? So we could use this summation formula to kind of extend what we know with trig. Right, so who cares about that? That was just like me having fun on a Thursday night. So let's actually get back to this limit. So if we have the sine of x plus h, this is going to be the sine of x cosine of h plus the cosine of x sine of h minus sine of x, didn't touch that, and over h, didn't touch that. Oh, there's still a limit there. My bad. So there's still a limit as h approaches 0. All right, so that's where that first hint was designed to help you out. The second thing is that we know something about the limit of sine x over x, right? We know that that's 1. And we also know from the previous homework and some other stuff that the limit of cosine of x minus 1 over x is equal to 0. Okay, so those are my next two hints. So here, right, we have a little bit of a sneaky way that we can rewrite this. So I'm going to look at this as sine of x cosine of h minus sine of x. I'm going to kind of group those terms together, right? I have this limit as h approaches 0, sine of x cosine of h minus sine of x, right? I can group those things together, plus the cosine of x sine of h. All these things still over h. So in this first term, I can now do some factoring, right? I can pull out the sine of x. So we have the limit as h approaches 0 of sine of x cosine of h minus 1 over h. Plus, I'm going to rewrite this now in terms of a broken fraction, cosine of x sine of h over h. And oh, look at this. We know something about the limit as something approaching 0 of cosine of something minus 1 over the same something. This thing should be 0. So this is going to be the sine of x times 0 plus, well, we know something about the sine of h over h. It's 1. So plus the cosine of x times 1, that's just going to be cosine of x. We've proved our derivative. We've maybe learned something about trig summation formulas. All in all, great day.